All right. This is unit two. So basically, same kind of thing as unit one. Um, the notes are skeletal notes. You go through, fill things out. Really, when you're doing all this at home, you want to make sure that you are getting a lot of things written down, writing things in the margins, and just making sure that you have really high quality notes. Because since you're not here at school, it's a big difference. So things I talk about, make sure you're writing them down. So okay, so this is the objectives. These are the different things that we're after in the curriculum, and so this unit is talking about the nucleus, and so what you're going to get into here is your electron configurations, and and then some things that we didn't talk about last year. So we'll talk about protons, neutrons, electrons, electron configurations, and then some new things, but there's still significant amount of review in this particular unit. The next unit, unit three, is where we get a lot of the items you haven't seen before. So take a look there. You can see electron configuration. And that's, if you don't remember electron configuration, that's like 1s2, 2s2, 2p6, like that kind of thing. So we'll kind of go over that. And there are some, sadly, there are some things we didn't teach you last year, so we are always kind of glossing over things in 10th grade to make it easier. But there are some specifics, some exceptions, some small lies that we told you that we're going to have to correct this year. So we'll go over that. And then a little bit of stuff about line spectrum, things like that. But there you go. There's some stuff on the left there. There's an orbital diagram right there. And then there's some configurations right there. So you start to see some things that you've seen before. And then this last bit talks about some things about light. So we've got the speed of light is being used, reason Planck's constant, some things like that. Just some little mathematical things that we'll look at. So as you can see, really just not that big of a unit. The first unit is definitely the biggest one, and this is significantly shorter. Two homeworks, couple of quizzes if we get to them. Have a lab. I may swap that out for something else just because of our time requirements. So I don't know if we're going to actually do that lab. We may do a different one. And then and that's kind of it. So I'm going to slide over here to the Jamboard and then kind of do everything on the Jamboard. So like I said, much smaller unit, and we'll get through this one quite a bit faster just because of the amount of content. So alrighty. So this is easy stuff, and I know sometimes students are like, well, where's all the new stuff? Well, sometimes it might be good to have some easy stuff because there's a ton of hard stuff here in IB, and so we do have to cover everything again, and we go over it pretty quickly. But this is stuff that you should be very, very familiar with. So we'll kind of start off here with this idea of the atom. All right, so what is the atom? So kind of think to yourself, okay, if they said what's the atom, like what would I think? What the heck is an atom? So hopefully you're thinking something little, right? Something small. We don't have like the ability to grab an atom. They're small. We have to model them. And so what I would write down for the atom is I would write down that it is going to be the smallest the smallest unit of an element. So if you have an element and it gets smaller and smaller and smaller, and you have less and less and less and less and less of your element, when you get to one atom of your element, that is as small of a piece of your element as you can get. So let's say you have like iron, and you have this piece of iron, this chunk of iron, right? And you just have the ability to make it smaller and smaller and smaller and smaller. At some point, you're going to get to that atom, and that atom is going to have protons, neutrons, electrons. But if you get smaller than this atom, then you're suddenly going into subatomic particles, right? So the atom is that smallest piece, because then we've got our protons, our neutrons, and our electrons. And so the atom is that smallest piece before we're no longer iron. Because see, when you get over here, these things are not unique to iron, right? Like protons, neutrons, electrons, those are not unique to iron. What's unique to iron is the fact that iron is the only thing that has the combination of 26 protons, right? So once we break that apart, there's nothing unique. So I'd write down for the atom that that's going to be the smallest unit of an element, the smallest unit of an element. It gets smaller than that, no guarantee that you have a specific element anymore. So you got building blocks, basically. You got Legos, right? So once you break apart the Harry Potter castle you bought, or the whatever Lego you bought, when you break it apart, well, now you just have the components, and that's basically what happens once you get smaller than the atom. Is that you go from iron now into individual components. So, all right. So you should know this. You should be able to fill this chart out. So go ahead and pause, fill this chart out, and you should have no problem doing that. So where the heck is the proton? Well, hopefully you remember the word nucleus. And the charge of the proton, hopefully you know that, +1. And then the neutron also hanging out in the nucleus. All the mass is in the nucleus. And then that guy's going to basically be a 0. And the electron is going to be outside the nucleus. And we would say that that is in the other name for that. Going to swap this over. Other name for that would be the electron cloud. So the electron cloud is that place where those little electrons get to buzz around and move and all that good stuff. So, and let's go ahead and give that a charge, and then we consider that a -1. So standard stuff should be pretty good on that. Okay. This is right over here. This format right there, that's what we're going to call a nuclear notation, or an atomic notation, or a nuclear symbol, or an atomic symbol. So nuclear notation, atomic notation, atomic symbol, nuclear symbol. Basically, it's taking and creating this format right here, which puts pieces in very specific places. Okay, so let's go ahead and look at those specific places. So in the upper left corner, I'm going to rewrite this, I think, just to make it a little bit easier to see. So we're going to have the A location, the Z location, and then the X. All right, so when we're looking at this, the A, that's the mass number. Okay, so that's the mass number. So what's the mass number? That's protons and neutrons. So A is your protons and your neutrons. So we can go ahead and write that in over here, mass number. So we go ahead and write down that that's the protons and the neutrons. You should already know this. This should not be anything particularly specific. So we're looking at just, things that you did last year, sophomore stuff, but still important stuff here. So let's take a look at the Z. So Z is kind of down here in this lower corner, and that's going to be your atomic number. Just going to get that from the periodic table, and so the atomic number is Z, and then so that's kind of right here, and then that's protons. I guess you could write that in like that. You can probably also write that you're going to get that from the periodic table. So I'm going to get this from the the periodic table might be useful to know. So I'm going to get the atomic number from the periodic table. So like say they give you the symbol, right? So they give you, in this case over here, carbon. Well, if they just gave you the carbon and you didn't know this bottom number, you just look it up on the periodic table and you'd be like, it's a 6. That's really easy. So with that, let's make one up here. So let's do magnesium. Okay. Well, what's the bottom number? Well, I'm going to look up magnesium on my periodic table, and it's going to be 12. All right, so you're just going to find that on the periodic table. Now that top number, you have to know protons in order to add that up. Okay, so what's an isotope? Isotope is going to be, and that's going to be 2 elements. So you've got 2 atoms, and they're the same element. The only thing they differ in is neutrons. And so isotopes are going to differ only in neutrons. So it's going to be same element. So both carbon, silicon, whatever, but they're going to have different neutrons, or going to have a different mass number, right? Because that's what the neutrons are giving us. So either way, and so these are examples of isotopes right here. Those are both isotopes. And those are isotopes of carbon. If I wanted to make a different one, I could make like a carbon-13. So that's another isotope, right? So there's a third isotope. So 3 different versions of carbon. And over here you have an example with aluminum. And so we got the mass number at 27, 13 off the periodic table. And so we'd have 13 protons, 13 electrons because there's no charge. And then the neutrons would be the top minus the bottom. So 27 minus 13. So the neutrons are going to be this. When we're finding neutrons, we just take that top number, 27, and we subtract that bottom number, 13. So it looks like a little subtraction problem for the neutrons. So no charge here. The charge would be in this position right here. And there's no charge, so then the protons and the electrons have to be the same. So some little stuff like that. All right, slide down here, and yep, that piece was for the next slide. So okay, that should take care of that. So slide over here. Okay, I'm gonna actually pause it here just because I have, I don't want to run out of time. But what you could do is you could come down here and try and fill out that chart at the bottom where it says nuclear symbol with, you could try and fill out this chart down here and see how you do.